Good afternoon, everyone, and welcome to another edition of Science with Mama J. Today we're going to be talking about electron configurations, and we're going to be relating it to the Bohr model. So, when you're looking at your electron configurations, there are a couple of rules that you do need to know, okay? First of all, energy levels and shells are equal to the same thing, okay? So you may hear me use it interchangeably. Energy levels equals electron shells. Okay? So, when you're looking at energy levels, you're looking at how many electrons are in each energy level. Okay? Because when you're creating your Bohr model, you have to know what the maximum number you can have is and how they're structured. Now, we're only going to be looking at the periodic table, the A group. So that is elements that are in groups 1A through 8A, or groups 1, 2, and 13 through 18. We're not going to be looking at transition metals today. So when you're looking at the energy levels, okay, the first shell or energy level can have a maximum of 2 electrons. Okay, the second energy level can have a maximum of 8 electrons. Now this is where things get a little bit complicated and interesting. The third energy level, because in the third energy level it's right before the transitions, but the transitions do a little bit of wonkiness. So the third energy level, it can have a maximum of 18 electrons, but it is happy with 8s. Okay, and the reason for that is because we start populating in the fourth energy level, we start populating the third energy level going above 8. So even though at the end of the third energy level we have 8 electrons, when we get down to the fourth energy level, we start back populating the third energy level in the transition metals. Okay, so the fourth energy level, okay, you can have a maximum of, 32 electrons, excuse me. 32 electrons, but again, it is happy with 8. Now, one thing to note, when you're looking at how electron shells work, electron configuration works, you will never ever have more than 8 electrons in the outer shell of your atom. So if you're in groups 1A through 8A, the outer shell is not going to have more than 8 electrons. Now, looking at your periodic table, if you take a look, and I have a periodic table sitting here, groups 1A through 2A, 3A, 4A, 5A, 6A, 7A, 8A, those groups, the number of electrons in their outer shell is equal to the group number. So if you're looking at group 1, it has 1 electron in its outer shell. Group 2 has 2 electrons in the outer shell. Group 3 has 3 electrons, 4 has 4, 5 has 5, 6 has 6, 7 has 7, and 8 has 8. And then when we're looking at the periods go across. The periods equal the number of electron shells or energy levels that particular element has. So for example, hydrogen and helium are in period 1, they have 1 energy level. But when you look at potassium is in period 4, it has 4 energy levels. So, taking a look at that, let's go ahead and start looking at the energy levels, populating them, and then relating that to the Bohr model. So I'm going to start with something very, very simple, okay? Hydrogen Hydrogen has an atomic number of 1. Okay, it is in period 1, group 1. So that means it has 1 energy level, and it has 1 electron in that energy level because it's a valence shell, which is the outermost shell, has 1 energy level, has 1 electron. So how does this look in the Bohr model? Well, if we went ahead and said hydrogen has 1 proton, it has no neutrons. Its atomic mass is 1.008. When you round that, it rounds to 1. So 1 minus 1 is 0. It has 0 neutrons. Okay? And its electrons, it has 1 electron. Okay? Now, if we were to look at something a little bit more complicated, let's go ahead and take a look at chlorine. Chlorine has an atomic number of 17. Okay, it is in period 3, and it is in group 7. Okay, so since it's in period 3, it has 3 energy levels or electron shells. Okay, so 1, 2, 3. And in the first shell, it has 2 electrons. In the second shell, it has 8 electrons. And in the third shell, it has 7 electrons. Now we can check our work and make sure we set this up properly. And how we do that is we count the number of electrons. Well, 2 plus 8 is 10 plus 8 is 17. Well, chlorine's atomic number is 17. It has 17 protons, and because all of the atoms on the periodic table are neutral, if it has 17 protons, it must have 17 electrons. So since we have 17 here and it matches, we've done our math correctly. So let's go ahead and see what that looks like in the Bohr model. So if we went ahead, okay, the number of protons is 17 and the number of neutrons is 18. Now how I got that, its atomic mass is 35.453 or 35.5. which is rounded to 35. Well, 35 minus 17 is 18. Okay, so in its first shell, it has 2 electrons. In its second shell, it has 8 electrons. Now, the reason why I follow this pattern is because electrons are going to repel each other. So you want to space them out as much as possible. You don't want to do 1, 2, 3, 4, 5, 6, 7, 8. Okay, you need to space them out as evenly and as much as possible because the electrons are going to repel each other. Okay? And we'll make the outside green since chlorine is a poisonous green gas. 1, 2, 3, 4, 5, 6, 7. It's got 7 electrons in the outer shell. Okay, and you get that from here, 2 in the first, 8 in the second, and 7 in the third. Okay, now we're going to go ahead and look at something that's a little bit more complex. Now, I'm not going to draw the Bohr model for this, but what I am going to do is explain how to find it. Okay, and some of you may have been paying attention to how I did this in class. But let's go ahead and take a look. So I'm going to take an element that's pretty far down on the periodic table, and I'm going to do the electron shell configuration for it. So I'm going to do one that we have not done in class. I'm going to go ahead and I'm going to do iodine. Okay, iodine's atomic number is 53. Okay, it is in period 5. And it is in group 7. Okay, so what that means, it has 5 shells. Okay, now we know if we go past the first to the second, the first must be full with 2. If we go past the second to the third energy level, then the second must be full with 8. Things get a little bit dicey here, so we're going to go ahead and we're going to skip down to the 5th one. Well, we do know that the 5th energy level must have 7 electrons because the number of electrons in the outer shell is equal to the group number. So, and that of course I believe is a happy coincidence. So that has 7. So let's go ahead and take a look. 2 plus 8 is 10 plus 7 is 17. Well, we have placed 17 of our 55 electrons, or 53 electrons, excuse me. So let's go ahead and do the math. We have 36 electrons left to place. Okay? So now, in the 3rd energy level, we said the maximum number we can have is 18. Well, 36 minus 18 is 18. That means we have 18 in the 3rd shell, and by default, last 18 in the 4th shell. So that is the correct electron configuration for iodine. So as you can see, there was a little bit of math involved, but it allowed us to be able to figure out what the shells were and how many electrons were in each shell. Now, one thing I do want to mention, not looking at the transition metals. So understand this is ignoring the transition metals because they do behave a little bit differently. When you're looking at the 3rd, 4th, 5th, and 6th shells, you're going to have only the numbers 32, 18, or 8. Okay? You're not going to have 12. You're not going to have 16. You're not going to have 31. These are the only numbers. So I looked at this and I said, well, the maximum number that I can have in the 3rd shell is 18. If we were looking at the 4th shell, so if we were looking at a heavier element that had more electrons, then we were looking at the 4th shell, we would see if 32 fit. And if it fit, then we would go ahead and deduct the difference. If we were looking at it not fitting, then we would go to the next smallest number, which would be 18. And I can actually go ahead and do that for you just so you have an idea. Okay, so I'm going to go ahead and erase this part, but I'm going to leave the shells up just to save a little bit of time or the energy levels. So I'm going to go ahead and I'm going to do lead. Okay, and because I've already done this one, but just to kind of show you how this works. Okay, lead's atomic number is 82. It is in period 6, and it is in group 4. Okay, so there's a 6th shell here. So we know first shell is 2, second shell is 8, and the last shell is 4. So looking at that, 2 plus 8 is 10 plus 4 is 14. So 82 minus 14. Oh, sorry. I'm jumping ahead of myself here. I apologize. So 82, I meant to do this. 7 minus 1 is 6. 12 minus 4 is 8. So I have 68 electrons left to place. Okay? The maximum number that I can take in the 3rd shell is 18. So 68 minus 18 gives me 50. So I have 18 here. The maximum number that I can place in the fourth shell is 32. 32 does in fact go in a 50. 50 minus 32 gives me 18. So there's 32 here and 18 here. And that is the electron configuration for lead. So I hope this was helpful and this helped clarify some of these a little bit and help you understand how to set up the Bohr model and how the Bohr model relates to the electron configuration. If you have any questions, please feel free to drop me a comment or go ahead and send me a message on Canvas. And I look forward to seeing you tomorrow. Have a great night, folks.